There's a lot in common between music and maths. If we look at the rhythm side of music, for example, the timing of it, then the timing is breaking down into consistent groups, consistent numbers, what we call the meter. So most songs have a meter of 4/4, which means that there are 4 beats in each bar. And that's sort of an inherent aspect of the music. The musician isn't even necessarily aware of it, but it's there in the music, and it makes the music sound more musical, having that consistent 4 beats in the bar. And then those 4 beats can be subdivided into smaller groups of 4, or maybe 3, or maybe even different subdivisions. And all of those different layers of rhythm, those different layers of numbers, is what gives rhythm its satisfying sound. So there's definitely maths in that side of music. But there's also maths in the pitch side of music. The intervals we hear between notes, they sound the way they do because of the ratio between the 2 notes. So for example, 2 notes that are an octave apart, their frequencies have a 2-to-1 ratio. If this A has the frequency of 220 Hz, then the A above it, the next octave up, will have double that frequency, 440 Hz. And that is precisely why they sound so satisfying together, because the 2 frequencies are perfectly slotting together thanks to that perfect ratio of 2-to-1. So the maths is really in the music. The reason we find certain intervals pleasing, like the perfect fifth or the perfect fourth or the octave, is because they have very simple, satisfying mathematic ratios going on between their different notes.